let's look at this week's stuff. Modulus. Right, so with modulus equations, for example, you take the modulus of x is equal to 3. What modulus means is absolute value. So when x is equal to 3, or x is equal to minus 3, that's what the modulus of x means. So we're dealing with absolute values here. So for example, if we were to take the first one, the modulus of x minus 1 is equal to 4. What that means is modulus of x minus 1 is equal to either plus 4 or minus 4. Right? Because we don't know whether we're dealing with a plus 4 or a minus 4, what we do is we solve this. Square both sides. Alright? The only way you can be sure that you're dealing with either positive or negative figures is if you square both sides and also 100% big. Positive. Alright? So we square both sides. We square x minus 1 and we square 4. So, you can either square out x minus 1 as normal x minus 1 by x minus 1, or the quick way to square out x minus 1 is square the first, twice the first by the second, square the second. Alright? So either way, whichever way you want to square out the brackets. So we square both sides. This becomes x squared minus 2x is equal to 4 to be squared, which is 16. X squared minus 2x minus 15 is equal to 0. And then you have to figure it out from here. Sorry? Double brackets, exactly. Minus b, double brackets, whichever it is. X plus 3 and x minus 5. So x is minus 3 and x plus 5. If we think about it, that makes sense. Because if you take this out here, x minus 1 is equal to, say we say plus 4 the first time, yeah? That x is equal to 4 plus 1, x is equal to 5. Or if x minus 1 is equal to minus 4, x is equal to minus 4 plus 1, x is equal to minus 3. There's your two answers. The reason we learn how to do it this way is we have a modulus on this side and modulus on this side, and these obviously get a lot harder. Is that alright? Right. What I want you to do is have a go at this one. Modulus of 3x minus 1 minus 4 is equal to 0. Try to solve that one. Right, let's have a little look at it. So, solve 3x minus 1 minus 4, right? First things first, 3x minus 1 is equal to 4. Move them either side to make it easy to square it out. Square it, square it. Square out this, square the first, 9x squared, plus twice the first by the second, plus square the last, is equal to 4 to be squared, which is 16. You can obviously square them out regularly, bracket, bracket, 3x minus 1 by 3x minus 1. So that's 9x squared minus 6x plus 1 is equal to 16. 9x squared minus 6x plus 1 minus 16 is equal to 0. 9x squared minus 6x minus 15 is equal to 0. Divide across by what to make your life a bit easier? 3x squared minus 2x minus 5 is equal to 0. Right, bracket, bracket. 3x and x, minus 2, 5 and 1, minus 5 plus 1. 3x squared minus 5x plus 3x, yeah, minus 5. 3x is equal to 5, x is equal to 5 over 3. And x is equal to minus 1. There are your two answers. Right, have a go at this one. So the modulus of 2x minus 1 minus x is equal to 0. Right, so first things first, moving one side, 2x minus 1 is equal to x. Square out both sides. That's square out the first, 4x squared, twice the first by the second. So that's minus 4x squared last plus 1 is equal to x squared. That's 4x squared minus 4x minus x squared plus 1 equals 0. That's 3x squared minus 4x plus 1 is equal to 0. Right, bracket, bracket. 3x and x. Minus 1 minus 1. 3x is equal to 1. X is equal to a third. X is equal to 1. 3 squared. Happy with that? Right, so these also get a bit harder. So the modulus of 3x plus 1 over modulus of x minus 1 is equal to 2. So, first things first, once again, we have to know whether we're dealing with positive or negative numbers, so we have to square both sides. So that's 3x plus 1 2 squared over x minus 1 2 squared is equal to 2 squared. So we now have 3x plus 1 2 squared is equal to 2 squared over x minus 1 2 squared. Any idea where we go from here? 4, you do that to make things a bit easier. Multiply across by x minus 1 2 squared. Get it off the bottom line. Get rid of your fractions as soon as you can. What happens to x minus 1 2 squared and x minus 1 2 squared? You're going to cancel. On the right hand side, you're going to get 2 squared times x minus 1 2 squared. So that then is 3x plus 1 2 squared is equal to 2 squared gives you 4, and then x minus 1 2 squared. You square this out and square out your left hand side. You're going to get square the first, twice the first by the second. Square the second is equal to 4 times square the first, twice the first by the second, square the second. Leaves you with 9x squared plus 6x plus 1 is equal to 4 times x squared minus 2x plus 1. Bring everything to multiply over 4 by that. You have 9x squared plus 6x plus 1 is equal to 4x squared minus 8x plus 4. Then you just simply quadratic space, you bring everything to one side. You have, bring over 4x squared, take away from 9x squared, you get 5x squared, bring over the minus 8x, you get plus, add 6, you get 14x. Bring over the plus 4 to the left, it becomes minus 4 plus 1, leaves you with minus 3. Then I just do bracket, 5x minus 1x plus 3, you get x equal to 1/5 and x equal to minus 3. So, these are the exact same modulus ones we were just doing. The only difference is, you got to multiply across by your bottom line to square on your left hand side and your right hand side to get rid of your fraction. Always try to get rid of your fraction as quick as possible, because that's what's going to cause the most hassle. Right, with that in mind, have a go at this one. Modulus of 2x plus 1 over x plus 2 is equal to half. Right, have a little look at it. So, we're going to solve 2x plus 1 over x plus 2 is equal to a half. So we square both sides. 2x plus 1 over x plus 2 squared is equal to a half to be squared. So, that is 2x plus 1 to be squared over x plus 2 to be squared is equal to 1 to be squared over 2 to be squared. Any idea what we'll do from here to make life easier? Multiply across by x plus 2 to be squared and 2 to be squared, x plus 2 to be squared and 2 to be squared. X plus 2 to be squared, x plus 2 to be squared cancel, 2 to be squared and 2 to be squared cancel, or 4, if you want to say 4, you can say 4. So that's 2 to be squared is 4 times 2x plus 1 to be squared is equal to 1 squared, which is 1 times x plus 2 to be squared. Or you can simply just cross multiply there, lads. If you want, if that's the way you learned it, you can cross multiply like that. Over there and over like that. So that's 4 times square out the first, 4x squared, twice the first by the second, 4x plus 1 is equal to 1 times square the first, x squared, twice the first by the second is 4x, square the last is 4. Right, 4 times 4x squared is 16x squared, 4 times 4x is 16x, 4 times 1 is 4, is equal to x squared plus 4x plus 4. Bring everything to one side and simplify. X squared comes over, 15x squared. 4x comes over, plus 12x. 4 comes over and they cancel with each other. You're left with 15x squared plus 12x is equal to 0. What I do? Minus b, guide number, or bracket. Can't do bracket here, there's only 2, so take out the highest common factor, which is 3x, you're left with 5x plus 4 is equal to 0. Line down the middle, 3x is equal to 0, x is equal to 0, 5x is equal to minus 4, x is equal to minus 4 over 5. Right, I'm going to go one of those. Right, x minus modulus of x minus 2 over 3 is equal to 1. Right. So, we square both sides. That is x minus 2 to be squared over 3 squared is equal to 1 to be squared. So that's x minus 2 to be squared is equal to 1 squared, which is 1 by 3 to be squared, yeah? That's square out the first, x squared minus twice the first by the second minus 4x plus square the last is 4 is equal to 9. You all happy so far? That's x squared minus 4x, bring over 9 because minus 9, so that's minus 5 is equal to 0. Bracket, bracket, x and x, minus 5 plus 1, x is equal to minus 1, and x is equal to 5. Alright? Right, something very like these then is when you have to deal with straight line. Is when you have to deal with surds. So we have the square root of x plus 7 plus the square root of x is equal to 7. Right. These are very like homogeneous equations. These are surd equations, and what we have to do here once again is make sure that our modulus, or in this term, in this instance, our surds, first of all, are on different sides of equals. Alright? First things first, you gotta make sure your surds are on different sides of equals. So we gotta move your x plus 7 is equal to 7 minus square root of x. This square root of x is to the right. And we square it out. So, we then square both sides. What happens when we square the square root? This square will cancel this square root. Why won't this square cancel with this square root? It's not over the full equation. Very, very important. Not over the full equation. It's only over the x. So what happens on your left-hand side is they cancel the square root of the square. On your right-hand side, though, you have to square out 7 minus root of x. So how do you square out 7 minus root of x? 7 minus root of x by 7 minus root of x. Because that's, you literally, is like saying x plus 3 to be squared. That's what you're actually doing. It's like squaring that out to put it by itself. Right. Adam, how are we going to square out 7 minus root of x and 7 minus root of x? How are we going to multiply this out? Yeah, so x plus 7, 7 by 7 is 49. Minus root of x by 7 is going to be what? Minus 7 root of x. Minus root of x or minus root of x is? Plus x. Alright. Can I simplify this a bit more? Minus 7 root of x and minus 7 root of x. Can I do anything with that? Yeah. That becomes minus 14 root of x. Alright, you treat them the same. Alright, they're the exact same, you treat them the same. So, your x and your x, they're going to cancel and you bring it over to be x minus x. You then have plus 7 minus 49 and minus 14 root x. So plus 7 and minus 49 equals minus 42 is equal to minus 14 root x. Anyone, any idea how I'm going to finish this off from here? No, they're stuck together. What I did last time I was stuck with square roots and trying to get rid of them. Square both sides. You want to get rid of them. They're stuck together this time, so you get rid of them. Minus 42 squared is 1,764. Minus 14 root x is minus 14 squared is 196. Root x squared and leave with just x. Divide across by 196 to get x on its own. X is equal to, you can't see it down here, but X is equal to 9. Right, we're going to have a go at one of these. Two x minus 1 is equal to the square root of 8x plus 1. Right, let's have a little look at it. So, first things first, they're on both sides, so we can square them out straight away. 2x minus 1 to be squared and square root of x plus 1 to be squared. Square this out, 4x squared, twice the first by the second, minus 4x, square the last plus 1 is equal to, that cancels, you're left with 8x plus 1. Bring everything to one side, 4x squared, 8x comes over, becomes minus 8x, minus 4x, minus 12x. 1's cancelled, you're left with 4x squared minus 12x is equal to 0. Take out a common 4x, you're left with x minus 3 is equal to 0, line down the middle. 4x is equal to 0, x is equal to 0, x is equal to 3. You happy with that, guys? Right, let's make these a bit harder. Let's start throwing them in together. The modulus of x plus 5 over the square root of 13 is equal to root 13. Right, this is like something now that would pop up in an exam paper. It's hard. That's root 13 on the right as well, yeah. So this is what will pop up in an exam paper usually at the beginning for about 10 marks. Right, let's have a little look at it. So, square both sides. So, easiest thing to do here is multiply across by the root of 13 to be squared both sides to get it off the bottom line. So, gone, gone. That's square the top, x squared plus twice the first by the second, 10x plus 25 is equal to root 13 to be squared by root 13 to be squared is just 13 by 13, which is 169, yeah? That's x squared plus 10x, 169 minus 169 plus 25, minus 144. Minus 144 is equal to 0. Bracket, bracket, x and x. 12 and 12 is going to work. What you get? 18 and 8 plus 18 minus 8. X is equal to minus 18. X equal to 8. That's about as hard as they get. Is that right? Right. Next thing we're going to look at. Something similar. Again. Inequalities. So, solve the following. And graph. You're always going to be asked to graph an inequality. So solve the following and graph it for me, guys. Two x minus 3 less than or equal to 4x minus 9. So this is just a basic one to get us going. 2x minus 3 less than or equal to 4x minus 9. It's the quadratics we focus on there. Let's just make sure we know where we're at. So we know what we're doing with graph, just like a number line. X is an element of, sorry, I should put that in with that. Oops. Right. X is an element of R. Right, let's have a little look at it. So, right, 2x minus 3 less than or equal to 4x minus 9. X is on one side. 2x minus 4x less than or equal to minus 9 plus 3. 2x minus 4x is minus 2x less than or equal to minus 9 plus 3 is minus 6. Divide across by minus 2. X is less than or equal to 3, is it? No. What happens? Got to change the sign, guys. Alright, that's why we do the basic ones first. Remember that rule. Why does the sign change on it? Anytime you divide by a negative number. Anytime you divide by a negative number, sign changes. The reason for this is, if I told you, we all know 3 is greater than minus 5, yeah? Divide both of them. I'll pick better numbers than that now. I'm going to pick 10. Right, we know 10 is greater than minus 5, yeah? Divide both of them by minus 1. What's this become? Minus 10. What does 5 become? Which is better? Which is greater? Sorry? 5 is greater, isn't it? That's why the sign changes. Whenever you divide by a negative number, you're changing the signs either side. And that's why the sign flips. Very, very important, alright? So, x is greater than 3. Number 9. Line down the middle. 3. Am I going up or am I going down? Oh, next number is 4, 5, 6, 7, and so on. Am I including 3 in it? Am I putting dots or am I highlighting it? Anyone, any idea? You're filling in the whole line. You're shading the whole line in. Why am I shading the whole line in? Real. Real numbers, alright? N stands for natural numbers. Z is your integers. When it's real, or you must highlight the whole line. Alright, very, very important. Right, we'll do another one of those just to make sure we're fully alright now. Nine times x plus 1 greater than or equal to 1 plus 2 times 5x plus 6, where x is an element of z. Right, let's look at it. So, one greater than or equal to 1 plus 2 times 5x plus 6, where x is an element of z. Right, 9 times x is 9x. 9 times 1 is 9. Greater than or equal to 1 plus 2 times 5x is 10x, 2 times 6 is 12. Move everything to one side. 10x comes over, take away from 9x, you're left to minus 1x. Greater than or equal to 1 and 12 is 13. 13 minus 9 is 4. Divide across by minus 1. X is less than or equal to minus 4. Number line. Minus 4, minus 5, minus 6, minus 7. We put dots and we include minus 4. The reason it's dots is it's z, and we include minus 4 because it says less than or equal to. Is that okay? Right. The reason we're jumping onto these is what we do when they're quadratic. Or what I want you to do is solve and graph for me. X squared minus 2x minus 8 less than or equal to 0. Solve and graph that for me. These are impossible to solve fully and get it right unless you graph it. Right, so if you look at that then, once again, bracket, less than or equal to 0. So it's x and x, minus 8 and minus 2, so that's minus 4 and plus 2. So that's x is equal to minus 2, and x is equal to 4, where they're less than or equal to 0. So, you must graph it to get this right. There's your little graph. There's 4, and there's 2. Right, is this U or N shaped? Very important. U. It's U shaped. So there's your U. Now, Faye, if it's less than 0, is it going to be above the line or below the line? Any idea? Below the line, exactly. There is your 0, so we want to, it's going to be below inside here. Inside in this spot right here. Right, so, if that's the case, we want to show that x is what then, Adam? So it should be minus 2. Exactly. Less than or equal to 4, because we want to show all the numbers which are less than or equal to 4, and all the way up as far as here, but it has to be greater than minus 2, because it goes above the line as you pass out minus 2. Right. Have a go at this one for me. Right, let's look at it. So, x squared minus 25 greater than or equal to 0. So that is bracket, difference of two squares, yeah? X and x minus 5 plus 5. So x is equal to minus 5, x is equal to 5. Right, draw our little graph. There is 5 and minus 5. U-shaped. Now, Adam, are we going above or below the line this time? So we want to show everything out here and everything out there. Alright? How are we going to show that, Adam? X is what then? X is greater than or equal to 5, all the numbers up here and are equal to minus 5, exactly. Because we want to show all the numbers out over here. So minus 5, minus 6, minus 7, minus 8. We want to show numbers greater than 5, 5, 6, 7, 8, 9, 10, and so on. Right, I'll go with this one. Right, let's have a little look at it. So, minus 2x squared minus 5x plus 12 is greater than 0. Right, first things first, what am I going to do with them? Yeah, so multiply by minus 1. So you said 2x squared plus 5x minus 12 greater than 0. Why do we flip the sign? You multiply by a negative number. If you divide or multiply by a negative number, you must flip the sign. Then you can do your bracket. So that's 2x and x. To get 5x, 4 and 3 or 6 and 2. 1 even, 4 2s are 8, yeah. Plus 4 minus 3, 2x squared plus 8x minus 3x minus 12, yeah. 2x equal to 3, x is equal to 3 over 2, x is equal to minus 4. Greater than 0. Draw your little graph. Minus 4, 3 over 2, U-shaped. Right, we want it greater than 0. So what? Below the line or above the line? Above, so out here and out here. That means x is what? Greater than 3 over 2 and less than minus 4. Right, and I'll go one of those. A few mistakes there. Example number 13. Two x minus 3 to be squared. 4. 4. Right, let's look at it. So, square out your bracket. 2x square the first, 4x squared. Twice the first by the second, minus 6x is minus 12x plus 9 greater than or equal to 4, yeah? That's 4x squared minus 12x, bring over your 4, becomes plus 5 greater than or equal to 0. Bracket, bracket, greater than or equal to 0. 4x and x. 5 and 1 is 20. No, that's not going to work. 2x and 2x. Minus 5 minus 1. Minus 5 minus 1. 2x equal to 1, x equal to a half. 2x equal to 5, x equal to 5 over 2. Draw your little graph. 5 over 2 and a half. U-shaped. Greater than 0, so you want it up here. And up here. X greater than or equal to 5 over 2. Less than or equal to a half. Right. Small bit harder again. Solve and graph this for me. X plus 3 over x minus 5 greater than or equal to 0. Anyone, any idea how we start? Do I multiply across by x minus 5 or x minus 5 to the square? Wait, if I multiply across by x minus 5 to the square. What's the first problem we ran into today when we started learning calculus? Very first thing we went to say, the sign change. Why do sign change? We multiply it over by one negative number. What happens if x here is 3? What number be? Minus 2. So that's why if you square it out, you know the number down here is positive. That's why you multiply the left hand side and the right hand side here by x minus 5 to the square. Alright? Here we go. No. Just multiply across by the bottom line squared. Don't forget, anything multiplied by 0 doesn't exist. Right, let's look at it so. X minus 5 to be squared, x minus 5 to be squared. One of the x minus 5's cancels with the squared. They're going to be left with nothing over there because anything times 0 is just going to be 0. So that's x minus 5 times x plus 3 greater than or equal to 0. X squared plus 3x minus 5x minus 15 greater than or equal to 0. X squared minus 2x minus 15 greater than or equal to 0. Bracket, bracket. X and x. 5 and 3 minus 5 plus 3. That then is x is equal to minus 3, x is equal to 5. Greater than or equal to 0, line down the middle, graph. 5 minus 3 U-shaped, where it's going to be greater than or equal to 0 out here and out here. X is greater than or equal to 5 and less than or equal to minus 3. Happy with that? Right, slightly harder one of those. Right, let's have a little look at it. So, x plus 2 to be squared and 2 to be squared, x plus 2 to be squared and 2 to be squared. Right, x plus 2 cancels with one of the 2's, 2 cancels with one of the 2's. So, you're left up here then with 4 times x plus 2 by 2x plus 1 less than or equal to 1 times 2 times x plus 2 to be squared. Yeah? That's 4 times 2x squared plus 1x plus 4x plus 2 less than 2 times x squared plus 4x plus 4. That's 4 times 2x squared plus 5x plus 2 less than 2 times 2x squared plus 8x plus 8. That's 8x squared plus 20x plus 8, then 2x squared plus 8x plus 8. 8's cancelled, 2x squared comes over, 2x squared from 8x squared is 6x squared, 8x comes over, becomes plus 12x, 12x less than 0. Take out a common 6x, you have x plus 2 less than 0, line down the middle, x is equal to 0, x is equal to minus 2. Draw your graph. Minus 2 and 0, U-shaped, where it's less than 0, so it's inside in here. That means x is less than minus 2, no it's not. X is less than 0, greater than minus 2. Any questions? All right, now a few multiplication mistakes, I'd say, was it? Right, so that is about as hard as they get. They do get slightly harder, and these have been known to show their heads on exam papers, is one that looks a bit like this. These are known as abstract inequalities. And they're proofs. So prove 1 over A plus 1 over B is greater than or equal to 4 over A plus B. Abstract inequality. sorry, I forgot to say here that A and B are both positive. They're both greater than 0. A and B are both greater than 0. They're both positive. No need to swear. Right, we have a little look at it. So, first things first, make this 1. AB, A into AB goes 1 times B, plus B into AB goes 1 times A, greater than or equal to 4 over A plus B. So that's B plus A over AB, greater than or equal to 4 over A plus B. Right, we can multiply across by A, B, and A plus B. The reason for that is, I was late saying it, but A and B is greater than 0. So you can simply say AB by A plus B, AB by A plus B. That cancels with that. That cancels with that. So that's B plus A by A plus B is greater than or equal to 4 times AB. That leaves you with AB plus B squared plus, so A by A, B by A is AB, B by B is B squared, A by A is plus A squared, A by B is plus AB. Greater than or equal to 4AB. That is A squared plus 2AB plus B squared greater than or equal to 4AB. Right. What am I going to do? So, bring over my 4AB, A squared plus 2AB minus 4AB plus B squared greater than or equal to 0. Then A squared minus 2AB plus B squared greater than or equal to 0. Any idea? Close. You were close to what you said the first time. Faye, any clue? Sorry, these are tough. That's why they're called abstract. You were saying A minus B by A plus B. So A minus B by A plus B is greater than or equal to 0. If we look at that, A by A will give me A squared, A by B will give me plus AB, minus B by A will give me minus AB, minus B by B will give me minus B squared. So it doesn't give me what I want. That doesn't give me what I want. You're on the right line though. How will I get what I want? A by A is A squared. A by minus B is minus AB. Minus B by A is minus AB. Minus B by minus B is plus B squared. How do I know that that is greater than 0 for a fact? Think about what we were doing with completing the square. Week 1 and week 2. They're the what? They're the same. How do I know A minus B to be squared is greater than 0? Anything squared is positive. Exactly. Brilliant. Anything squared is positive. So greater than 0. Right, last one of the day. I'll go with this. Last week algebra, next week logarithm, probably will go on for a bit longer than an hour and a half. Probably will go on 45 for a bit longer. Because it's a lot. So you need your logbook. You be staring at walls if you want to log. One more minute, please. Right. A squared greater than or equal to minus 2a squared b minus 10 ab squared. Right, everything to the one side. A squared minus 2a squared b, plus 2a squared b plus 10ab squared greater than or equal to 0. Right, what are we going to do? Highest common factor, right? We can go with that. What's the highest common factor? A, right? Take out the common A, we're left with A plus 2ab plus 10b squared. Right? Where do we go from here? Can we factorize them? See if you can factorize inside the bracket. Go on 1 minute, see if you can factorize inside the bracket. Sorry? Right, let's see if I can have a go at it. So you can factorize the end to AB, A squared, 10AB squared. Can I add them together? A squared and 2A. Take down the question. 2 seconds. Minus 2. No, I didn't take down the question right. That would help the whole situation. Apologies. I was wondering, because I was running into a wall myself. Minus 2b, not ab. Right, go back and see if you can do it now this time. Apologies. That should be an b, not an ab. Yeah, minus 2b times a. Generally, when it comes to something like this, look for factorizing. 5 over 2. Plus 2b. Squared. Right, see if I can whack off of this time. A squared greater than or equal to minus 2ab minus 10b squared. That's a squared plus 2ab plus 10b squared greater than or equal to 0. Bracket, bracket. A and A. Minus 5b minus 2b minus 2ab using minus 7ab. Ten and 1 is not going to work. 5 and 2, they're the only factors of 10. No. Guide number. Give you 2, 10 and 1, 5 and 2. No, it's going to give you 3. I have to jump back to the next day, guys. I can't see it. Okay, so I think we'll have to jump back to the next day. I can't see what we're supposed to do there. 5 and 2, 10 and 1. Minus. What? Yeah. But especially when it's 3 terms, like, it has to be factorized in double brackets. Yeah, right. See if I can figure it out for next day, unless there's a mistake in the question.